Okay, so good morning, everyone. Welcome back. We're going to talk about chapter 8 today. Okay, so the first section on chapter 8, we're going to talk about sequence and series. Okay, so there are two topics that we're going to talk about on this section 8.1. The first portion of this section 8.1, we're going to talk about sequences. And then the second portion of this section 8.1, we're going to talk about series. Okay, so let's begin, everyone. So let's talk about sequence. So let's take a look up a few definitions of a sequence first. So a sequence is a function where the domain is a set of consecutive positive integers beginning with 1. So consecutive, it means that the numbers can be next together. Positive integers are going to be 1, 2, 3, 4, 5, beginning with 1. So 1, 2, 3, 4, 5, 6, 7, etc. So that's the definition of a sequence. Now, the next definition we're going to talk about is an infinite sequence. An infinite sequence is a function having for its domain is the set of positive integers. So this is infinite, so it's not going to stop. It's going to keep going forever. The value for the domain is going to be positive, consecutive integers. So 1, 2, 3, 4, 5, 6, 7, etc. Right on the way to positive infinitive, if it's possible, right? So it's infinite sequence. So the sequence is going to keep going. The domains of that sequence is going to keep going. A finite sequence. Okay, so a finite sequence is a function having its domain the set of positive integer from 1, 2, 3, 4, 5 up to n for some positive integer. So the difference between infinite and finite sequence is finite, we're going to know where it's going to stop, right? But infinite, we're not going to know when that series, when that sequence is going to stop. So for example, let's take a look at this example as an example of a sequence. Consider the following sequence. So a sub n is equal to the power n. So the values of the term already depend on the values of n. Some of the function values also knows the term. So the function values or the output gonna be the term of the sequence. So for example, now I'm gonna try when n is equal 1, right? So when n is equal 1, we have a sub 1 equal to the 2 to the power 1 would be 2. When n is equal to 2, we have a sub 2 because we're going to substitute n is equal to 2. So we have a sub 2 is equal to the power 2, which is 4. When n is equal to 3, we have the third term, which is a sub 3 is equal to the power 3. So the answer will be 8. When n is equal to 4, we have a sub 4, the fourth term of the sequence. We have equal to the power 4 is equal 16 and etc. So we have the first term is a1, the second term is a2, the third term is a3, the fourth term is a4, and etc. The first term of the sequence is denoted as a sub 1, and then the third term is denoted as a sub 3, and the inner term or the general term of this sequence is denoted as a sub n. So this sequence can also be denoted as, so you might list out one of the sequence. So you're gonna list out one of the term. You're gonna list a few terms of the sequence. That's just another way that we can show a sequence. So we're gonna have the first term be 2, the second term be 4, the third term be 8, the fourth term is 16, and then the fifth term is 32, and etc. Okay. So there are two different ways that you can list a sequence. You might using the general term if it's easy to show the general term, or you might just list out a few terms of the sequence. Okay. So this is the definition of a sequence. We have the definition for a sequence, an infinite sequence, and a finite sequence. Okay, so let's do some practice questions related with the sequence. Okay. Okay, so in each of the following, the nth term of a sequence is given. Find the first 4 terms. Okay, so find the first 4 terms, it means that, what does it mean by that? So find the first 4 terms, it means that you have to find out A1, A2, A3, A4. And then you also need to find out A10 and then A15. Okay, so find the first 4 terms, which is A1, A2, A3, A4. Okay, so that's going to be the first 4 terms. A10 it means the 10th term, yeah, so the 10th terms of the sequence, and A15 is the 15th terms of the sequence. Okay. So for example, we're gonna do the first one. So n is equal n squared minus 1. Okay, so we're going to do the first 4 terms. So the first 4 terms, it means that when n is equal 1. Okay, so the first term when n is equal 1. So we have a1 is equal 1 to the power 2 minus 1. So 1 to the power 2 is 1, take a 1, so it's going to be 0. Okay, now we're going to find out the second term when n is equal 2. So the second term, we're going to substitute n equal 2. So we have a2 equal 2 to the power 2 minus 1. So 2 to the power 2 is 4, take away 1, so going to be 3. Now we're going to find out the third term, which is n equal 3. When n is equal to 3, it's going to give you the third term, a3 is equal 3 to the power 2 minus 1. 3 to the power 2 is 9, take away 1, so going to be 8. Now the fourth term is mean that when n is equal 4, so we're going to get a4 equal 4 to the power 2 minus 1. So going to be 4 to the power 2 is 16, take away 1, so going to be 15. Okay, so those are the first 4 terms of this sequence. Now we're going to find out the next term would be A10, right? So the question also asking about A10. So A10, what does it mean by A10? So A10, it means that we're going to plug in n is equal 10, right? So n is equal 10. So we have A10 equal 10 to the power 2. We substitute n by 10 minus 1. So 10 to the power 2 is 100, take away 1, so going to be 99. Okay, so that's going to be the 10th term. Now A15, it means that we're going to substitute n equal 15. So we have A15. So A15 equal 15 raised to the power 2, take away 1. So 15 to the power 2 is 225, right? Minus 1, so going to be 224. Okay. There you go. So there's either a few terms of the sequence, the first 4 terms of the given sequence, the 10th term of the sequence, and the 15th term of the sequence. Okay. So you have to find out the values of n. We're going to substitute look like n is going to be the input or the domains, and then you're going to calculate an. It's going to be the output. Okay. So it's a function, right? So a sequence is a function. Okay, now we can try the next example together, everyone. Okay, so let's see. Okay, so it's going to be the same kinds of question. We need to find out the first 4 terms, the 10 terms, and the 15 term of this given sequence, right? Okay, so we're going to try when n is equal 1. Okay, so when n is equal 1, we have a1 equal, what is it? It's equal 1 minus 1 times 1 minus 2 times 1 minus 3. Okay. So what's the answer of this? Okay. So we have 1 minus 1 is going to be 0, right? So 0 times whatever over here is going to give you a 0. So the first term is just a 0. Okay. Now similar idea, we're going to try the second term when n is equal to 2. We're going to get a2 is equal. It's going to be 2 minus 1. 2 minus 2, and then 2 minus 3. We substitute n by 2. Okay, what's the answer? So for the middle factors over here, 2 take away 2, 2 take away 2 is going to be 0. So 0 times whatever is over here is going to give you a 0. Now we're going to try the third term when n is equal to 3. So going to give you a3 is equal 3 take away 1. 3 take away 2, and then 3 take away 3. Okay, so what's the answers, everyone? So once again, the third calculation, we have 3 take away 3, which is 0. So 0 times whatever before that's going to give you a 0. Okay. Now we're going to try the fourth term when n is equal 4. We're going to find out a4 equal. It's going to be 4 take away 1. 4 take away 2, and then 4 take away 3. So what's going to be the answer of this? 4 take away 1 is going to be 3. 4 take away 2 going to be 2. So 3 times 2 is 6, right? And 4 take away 1 is going to be 1. 4 take away 3 is going to be 1, right? So it's going to be 3 times 2 times 1, which is 6. Okay. Okay, so this is the first 4 terms of this given sequence, right? Now we're going to find out the 10th term. We're going to substitute n is equal 10. So when n equal 10, they're going to give you a 10. So we're going to substitute n by 10. So 10 take away 1, 10 take away 2, and then 10 take away 3. Okay, so what's going to be the answer? So 10 take away 1 is going to be 9. 10 take away 2 is going to be 8. And then 10 take away 3 is going to be 7. So it's going to be 9 times 8 times 7, right? That's using your calculator to get the answer quicker. What is it? Let's find out. So 9 times 8 times 7 is going to be 504. Okay, so that's the 10 term, right? Now we have the 15 terms over here. So similar concept, we're going to try when n is equal to 15. We have a 15. It means that we're going to substitute n by 15. So 15 take away 1, 15 take away 2, and 15 take away 3. Okay, so 15 take away 1 is going to be 14. So we have 14 times it by 15 take away 2 is going to be 13. And then times it by 15 take away 2, the 3 is going to be 12. Okay, so 14 times 13 times 12 is going to be 2184. Okay, so 2184. Okay. So this is the second example. We just find out the first 4 terms of the given sequence. And we also get the 10 terms and the 15 terms of the sequence. Okay, so far so good. Easy. Okay. Now we're going to try proxies also. So everyone, it's going to be the same ideas again. We're going to try the first 4 terms, the 10 term, and the 15 term, right? Okay. So when n is equal 1, okay, so it's going to be a1 equal, we have negative 1 raised to the power 1 times by 1 to the power 2. Okay. So negative 1 to the power 1 is negative 1, right? 1 to the power 2 is 1. So negative 1 times 1 is going to be negative 1. Okay. Now, similar concept, we're going to try when n is equal to 2 to find out the second term, a2. It's going to be negative 1 raised to the power 2 times 2 to the power 2, which is negative 1 to the power 2 is positive 1, 2 to the power 2 is 4, so it's going to be 4. Now, the third term when n is equal to 3 is going to give you the third term a3 is equal negative 1 to the power 3. We're going to substitute n by 3 because we calculate the third term, so n is equal to 3. We substitute n equal to 3 into the general terms, so to find out the third terms, right? So it's going to be 3 to the power 2. So what is it? Negative 1 to the power 3 is negative 1 times it by 3 to the power 2 is 9. So it's going to be negative 9. Okay. Now, similar idea. Let's find out the fourth term when n is equal 4. It's going to give you a4 is equal negative 1 to the power 4 times it by 4 to the power 2. Okay, so what's the answer of this? It's going to be negative 1 to the power 4 is positive 1. 4 to the power 2 is 16, so the answer is going to be 16. So based on the sequence that we have, based on the term of the sequence that we have so far, we're going to call this sequence is an alternative sequence, right? Alternative sequence, because the terms are going to be changing the sign from negative, positive, negative, positive. It alternates the sign, alternative sequence. Okay. Now we're going to find out the 10 terms of n is equal 10, right? Okay, so n is equal 10, so we're going to give you a 10 equal negative 1 to the power 10 times it by 10 to the power 2. Okay, negative 1 to the power 10 is going to give you positive 1, and 10 to the power 2 is equal 100, so this is going to be positive 100. Okay, now similar concept, we're going to find out the 15 term of this sequence. So when n is equal 15, we're going to find out a 15 is equal negative 1 to the power 15 times it by 15 to the power 2. Okay, so a negative number raised to an odd power, the answer is going to be negative, right? So negative 1 to the power 15 is negative 1. And then 15 to the power 2 is 225, so the answer is negative 225. Okay. So this is just a few practical questions, how we're going to find out a few terms of the sequence. Okay. Okay, so a sequence looks like it's going to be a function, right? We know the inputs are going to be positive integers, consecutive positive integers, and then the outputs are going to be the general term an. Okay. Okay, so now let's move on to the next kind of question. Finding the general term. Okay, so sometimes the question gonna give you the general term. They asking you to find out a few terms of that sequence, but sometimes they're gonna give you a list of a sequence, the list of the term of the sequence, and you have to come up with the general terms of that sequence. Okay. Finding the general term. So when only the first few terms of a sequence are given, we do not know what the general terms gonna be, right? But we might be able to make a prediction or estimation by looking for a pattern or a rule that it might apply, right? Okay, so looking for a pattern. Okay, so the same rule applies over and over. Okay. So for example, let's take a look at the example and hopefully you might come up with the general terms an. Okay. So in order to help us to come up with the general terms, I'm going to do look like what we did earlier. When n is equal 1, we have the first term a1 is equal 3, right? So that's what the question gives you. Now, when n is equal 2, we have the second term a2 is equal 9, okay? When n is equal 3, we have the third term a3 is equal 27, which it looks like observing any pattern it happened based on the values of n and some number, okay? And a similar idea, when n is equal 4, we have a4 is equal 81, okay? And then etc. So what should be the general terms of this an? Okay, so what's it going to be the general terms an? Okay, so now we're gonna find out an. So what's gonna be the general term a sub n? Okay, an is equal what? Okay, so the first term is 3, the second term is 9, the third term is 27, the fourth term is 81. So look like what happened. You can apply any rule over here, right? So you can see that, oh, look like when n is equal 1, we have 3 to the power 1, right? Which is 3. When n is equal 2, we have a2 is equal maybe 3 to the power 2, which is 9. When n is equal 3, we have the third term is 27, which is 3 to the power 3. When n is equal 4, we have the fourth term, which is 81, which is 3 to the power 4. So the general term we might, it might be 3 to the power n. Okay. So the general terms are going to be 3 to the power n. When you substitute n is equal 1, we have the first term is 3. When you substitute n is equal 2, we have 3 to the power 2, which is 9. When you substitute n is equal 3, we have 3 to the power 3, which is 27, and etc. Okay, so we have the answer for the general terms. They're going to be 3 to the power n. Okay. So sometimes it might be easy to identify the general term, but sometimes it takes a little bit more work, more time. It takes a lot of effort to come up with maybe the general term when you recognize the general pattern of the sequence. Okay, now let's try the next one. Okay, we are given another sequence. So the first term is square root of 2. The second term is square root of, square root of 2. The third term is square root of 6, and then it's going to be similar. Okay, so let's find out what's in the general terms. Okay, so let's find out the general terms of this sequence, everyone. Okay, so we have when n is equal 1, we have a1 is equal square root of 2. Okay, so it's equal square root of 2. When n is equal 2, we have a2 is equal 2, which is, I think that's maybe square root of 4, right? So square root of 4 is going to give you 2. Now n is equal 3. we have A3 is equal square root of 6. Okay. And then similar idea, we have n is equal 4. We have A4 is equal square root of, oh, it's 2 square root of 2. It's going to be 2 square root of 2. Okay. I'm going to rewrite in terms of the single square root. It's going to be square root of 8. Okay. There you go. So now we need to find out the general terms. Okay. So what's going to be the general term of this sequence, everyone? Let's give it a try. So what's it going to be? A sub n. Okay, so what's going to be the general term? So when n is equal 1, we have localized it's going to be square root of 2. When n is equal to 2, we have the answer going to be 2 square root of 4. And then when n is equal to 3, we have A3 is equal square root of 6. So look like all of the term over here going to be a square root, right? So it's going to be square root of what? When n is equal 1, we have square root of 2. When n is equal to 2, we have square root of 4. So look like that's going to be an even number. It's a multiples of n. It's going to be double the n, right? It's going to be 2n. When n is equal 1, we have 2 times 1 is 2, square root of 2. When n is equal to 2, we have 2 times 2 is equal 4. Square root of 4 is going to give you 2. When n is equal to 3, we have 2 times 3 would be 6. Square root of 6. When n is equal to 4, we have 2 times 4 is equal to 8. So we have 2 square root of 2. So look like the general terms are going to be an is equal square root of 2 times n. Okay. So based on the list of a few terms, we might do some prediction to estimate what should be the general term of a sequence based on the pattern that you might observing. So then the answer might be different. It might be different possible. You might come up with another pattern. If it's work, then that should be okay. Okay, so now after we know how to list out a sequence, now we're going to talk about sum and series. So the sum of a sequence and series. Okay. So given an infinite sequence, we have A1, A2, A3, A4, up to AN, and then it's going to go up to infinities also. The sum of the terms, so when you add them up, so when you take A1 plus A2 plus A3 plus A4 plus A5 plus dot AN, and then on the way up. We call it an infinite series. So the sum of all of the term in the sequence is going to give you an infinite series. It's going to give you a series. And then in this case, we're not going to know where we're going to stop. So that's why it's going to be infinite series. A partial sum of the sum of the first n terms. If you only focus on the first n term, it means that we take A1 plus A2 plus A3 plus A4 plus A5 plus dot up to AN. This is just the partial sum of the first n terms. It's going to give you just a finite sum. Okay, it's finite sum. A partial sum is called a finite series. A finite sums are going to be a finite series. Or the n partial sum, or n is denoted by Sn. So the letter S is stand for the sum, right? So sum of the first n term. So Sn, the sum of the first n terms. So the sum of the first n terms. Okay. So that's the definition, right? So we have the definition for a series. So we have infinite series and we have finite series, right? Infinite series and finite series. Okay. So now let's give it a try, right? So a series is the sum of the term of a sequence. That's going to be a series, right? Okay, so find the indicate partial sum of the sequence. Okay. So they're asking us to find out S1, S2. Okay, so S sub 2. So S2 it means that we take A1 plus A2. It's only the sum of the first two terms, right? So what are they? What's the first term? The first term is going to be 1 plus the second term is negative 3. So the answer is going to be negative 2. So this is the sum of the first two terms. Okay. Now, similar idea, we can find out S5. So what does it mean by S5? So S5 is the sum of the first 5 terms, right? So it's equal A1 plus A2 plus A3 plus A4 plus A5. So now let's see what's the A1. So A1 is equal 1, A2 is equal -3 plus A3, which is 5. And then A4, 1, 2, 3, 4, -7, and plus A5 is going to be 9. So let's see what's the answer of this. So 1 plus a -3 is a -2 plus a 5. So it's going to be positive 3. Then minus 7, so it's going to be -4, right? -4. -4 plus 9, so going to be positive 5. Okay, so let's see if that's going to be true. 15, take away 10 is going to be 5. Okay, so S1 is the, oh, sorry, this is S2. So S2 is the sum of the first 2 terms, and then S5 is the sum of the first 5 terms. So you're going to do the addition for the first 5 terms, that's going to be S5. If you're going to do addition for the first 2 terms, it's going to be the S2. So S sub n is the sum of the first n terms. Okay. Now, similar idea, we can do something similar also, right? It's going to be S1. Okay. So what does it mean by S1? So S1 is the sum of the first 1 term, right? Sum of the first 1 term, which is just A1, and A1 is equal 1. So that's all. Now, similar idea, we can do S5. So S5 is going to be the sum of the first 5 terms, right? So it's going to be the sum of the first 5 terms. Is equal A1 plus A2 plus A3 plus A4 plus A5. Okay. So what's the A1? So A1 is A1 plus A2 is A1 4 plus A3 is A1 over 9 plus A4, which is 1 over 16 plus A5 is going to be 1 over 25. Okay. Now I'm going to use my calculator to get the answer for this. It's going to be quicker, right? So we have 1 plus 1 divided by 4 plus, oh, it's the division, plus 1 divided by 9 plus 1 divided by 16 plus 1 divided by 25. Okay. And for my calculator, I have the option that I'm going to keep the answers as a fraction also. Okay, so this is going to be the answer in terms of fraction. 2569 is over 3600. Okay, so 2569 is over 3600. Okay. So S sub n is the sum of the first n term, or it's going to be partial sum of the first n terms. Yeah, it's going to be n partial sum. Okay, so we have the second portion, which is a series, right? Okay, so let's see what we have next for the series. Okay, so the next thing we're going to talk about is a sigma notation. Sigma notation. So the Greek letter, this is the sigma. Okay, so this is the notation for the summation or sigma. Okay, the Greek letter sigmas can be used to denote the sum, a sum, right? So sigmas is represent a sum. When the general terms of a sequence is a formula. When the general term of a sequence is a formula. So for example, the sum of the first 4 terms of the sequence. So we are given a sequence look like 3, 5, 7, 9. It's going to be the sum of the odd number, right? Not include 1, okay? Can be named as follow using sigma notation or summation notation. It's sigma notation or summation notation. So it's going to be 2k plus 1 for k is equal 1 up to 4. Okay, so this is the sum of the first 4 terms. The sum of the first 4 terms, so that's why k is equal 1 up to 4. If you're going to do the sum of the first 5 terms, then k is equal 1 to 5. And if you're going to do the sum of the first 10 terms, then k is equal 1 to 10. Okay, so that's how we're going to get the sum of the first n term, the sum of the first n term using sigma notation or summation notation. So the sigma notation, it might be easier, it's more condensed, but it's only applied when we know the general terms is a formula. If the general terms is a formula, or if you can recognize the general terms of a sequence. Okay. This is read as the sum is k go from 1 to 4 up to k plus 1. That's how we read this sigma notation or summation notation. The letter k is called the index of the summation. The index of the summation might start at a number other than 1. A letter other than k can be used also. So in this case, we're using a letter k, but you might use any other letter. That should be okay. And the values of k for this notation is start at 1, but you might using the initial values of this case at any other number is also work. Okay. So this is the sigma notation or summation notation. It represents an addition or the sum. Okay, summation. Okay, so now let's find out this, right? Okay, so for example, let's give it a try. We have k is equal for the summation of k is equal 4 up to 7. Okay, so the summation, the sum a k go from 4 to 7 of these terms, right? Okay, so the sum when k is equal 4 up to 7. So in this case, k start at 4, right? So what we're gonna do, we're gonna take the square root of, we're gonna plug in k is equal 4. So it's gonna be 2 times it by 4 minus 1. So that's gonna be the first term plus, now after we plug in k is equal 4, we're gonna plug in k is equal 5, right? So after 4 is gonna be 5, so it's gonna be 2 times it by 5, take away 1, plus, now, and then we're gonna have the square root of what is it? Now after 5 is gonna be 6, so 2 times it by 6 minus 1, plus what is gonna be the next terms? It's gonna be 2 times it by, so 4, 5, 6, now 7, plus 1. Okay, so equal. Okay, so that's how we expand the summation, right? We just rewrite a sigma notation or the summation notation as addition. So the first, we start with k is equal 4. So we substitute k is equal 4, and then k is equal 5, and then k is equal 6, and k is up to 7. Okay, now so it's gonna be equal 5, equal what? Let's simplify it. So 2 times 4 is 8, take away 1, so it's gonna be square root of 7. Plus, now 2 times 5 is 10, take away 1, so it's gonna be 9, so it's gonna be square root of 9, plus, now 2 times 6 is gonna be 12, minus 1, so it's gonna be square root of 11. Plus, and now 2 times 7, or this is minus 1. So 2 times 7 is 14, take away 1, so it's gonna be 13, so it's gonna be square root of 13. So the only term that you might need to simplify is square root of 9, right? So we know square root of 9, which is 3, right? So it's gonna be square root of 9, so equal 3. So square root of 9 is gonna be 3. There you go. So this is gonna be the sum right here. Okay. Now ready? Let's give it a try for the next one, right? Okay. So now we have the summation, the sum of i. Yeah, so it's no longer the variable k, it's gonna be the variable I. So I go from 1 to 5 up I minus 1, I plus 3, so over I plus 3. So it's means that we're gonna substitute I is equal 1 up to I is equal 5. Okay, so let's see what we're gonna get. So we're gonna start when I is equal 1. So it's gonna be 1, take away 1, divided by 1 plus 3. That's in the first terms when I is equal 1. Now similar idea where I'm gonna plug in when I is equal 2. So it's gonna be 2 take away 1 over 2 plus 3. Okay. Now I'm gonna try when I is equal 3. So when 1, 2, and 3. So it's gonna be 3 take away 1 over 3 plus 3. Okay. Plus, now I is equal 4. So it's gonna be 4 take away 1. 4 plus 3. One more term, the fifth term, right? So now the fifth term, when I is equal 5, it's going to be 5 take away 1 over 5 plus 3. Okay, it's equal. Now 1 take away 1 is going to be 0. 0 over 4 is going to be 0. So 0 plus, now 2 take away 1 is going to be 1. 2 plus 3 is going to be 5, so plus 1/5 plus. And now 3 take away 1 is going to be 2. Divided by 6. And you might need to reduce in this, right? So 2 over 6 is with a 1 over 3. So I'm going to leave it 2 over 6 for now, plus. And now what it's going to be? 4 take away 1 is going to be 3, divided by 4 plus 3 is going to be 7, plus. Now 5 take away 1 is going to be 4, divided by 5 plus 3 is going to be 8. That's going to be 8. Okay. And then you might use a calculator to get the answer of this approximation. And you might need to simplify some of the fraction that we have over here if it's possible to simplify it more. Okay, so 0 is just a 0. So I can drop out that 0. Now we have this is 2 over 6. Sorry, 2 over 6. Yeah, so 2 over 6, we can simplify that to get 1 over 3, right, to make the fraction look smaller. And then 4 over 8, we can simplify that to have 1 over 2 to make the fraction look smaller. Okay, and then you're going to use a calculator to get the answer of this summation if it's possible, right? So you're going to get the calculator to get the answer of this. So 1/5 plus 1/3 plus 3/7 plus 1/2, what's going to be the answer? Let me use in my calculators real quick. We have 1/5, 1 divided by 5 plus 1 divided by 3 plus 3 divided by 7 plus 1 divided by 2. And I'm going to keep the answer as a fraction. So 307 over 210. So 307 divided by 210, that's going to be the answer. Okay. So that's just a few practical questions of how we're going to use and how we expand the summation notation, right? So what does it mean by the summation notation? So summation notation or sigma notation, it's going to be the sum, look like of the sum of a few terms of a sequence. It's going to be the sum, summation notation or sigma. Okay, similar idea, we can try the next question, right? Okay, so this one, k is equal 0. Okay, so we have -2 to the power. It's going to be 2 times 0. Okay, plus, now we have -2 to the power. It's going to be k is equal 1, so it's going to be 2 times it by 1. Plus, -2 to the power 2 times it by 0, 1, now 2. Plus -2 to the power 2 times it by 3. So because this is the summation, k go from 0 to 3. So that's why 0, 1, 2, 3. So we're going to substitute k's by 1, 0, 1, 2, and 3. Now let's see what we're going to get, right? 2 times 0, 2 times 0 is 0. Any number raised to the power 0, right? A non-zero number raised to the power 0 is going to be 1 plus 2 to the power 2 times 1 is 2. -2 to the power 2 is going to give you +4, right? -2 to the power 2. -2 times -2 is +4. Now we have 2 times 2 is 4. -2 to the power 4. -2 to the power 4. 2 to the power 4. It's going to be 16. Plus, now we have 2 times 3 is 6, right? So it's going to be -2 to the power 6. -2 to the power 6. It's going to be 64. Okay, now we're going to add them up, right? So it's going to be 1 plus 4 plus 16 plus 64. It's going to be 85. So this is the final answer, the sum. Okay, the summation. Okay. Okay, so that's just a few practical questions of how we're using sigma notation, right? Okay, so let's move on to the next portion. Okay, so now let's try it. Okay, so write a sigma notation for each of the following sum, right? Okay, so we can see, okay, so the first term, the second term, the third term, the fourth term, and the fifth term, right? So we might use that when k is equal 1 to 5, okay. Okay, so sigma notation, let's see if I can have it right here. Okay, so you can use in any variables. I'm going to use in k is equal 1 up to 5. Okay, so we have the first term, the second term, the third term, the fourth term, and the fifth term. So k is equal 1 up to 5. Now the first term is 7, the second term is 14, the third term is 21, 24, 35. Look like they are multiples of 7, right? So it's going to be 7k, right? When k is equal 1, we have 7 times 1 is equal 7. When k is equal 2, 7 times 2 is equal 14. When k is equal 3, we have 7 times 3 is 21, and etc. The fourth term and the fifth term. So this is going to be the sigma notation. Okay, how about the next one? Okay, so we have 1, 2, 3, 4, 5, 6. So you can use in the letter K, or you can use in the variable I. So let's use in the K is equal 1 up to, what is it? 1, 2, 3, 4, 5, 6. It's gonna be 6 of what? And you can see that the size is alternate, right? So the size is gonna be alternate over here. Okay, so the first term is 2, the second term is -4, the third term is 8, and it's going to be alternate sign. So most of the time, whenever we have alternate sign, you have to use in the term -1. But to the power what? To the power n, to the power k. But let's see if this case is not true when k is equal 1. So we have -1 to the power 1 is -1. That's not good, right? You want to get the positive, so it's going to be to the power k plus 1. And then 2 to the power k. Okay, let's see if it's true. When k is equal 1, we have 1 plus 1 is 2, -1 to the power 2 is going to be positive 1, and then 2 to the power 1, which is 2. When k is equal 2, we have 2 plus 1 is 3, -1 to the power 3 is -1 to the power 3 is -1, and then 2 to the power 2 was 4. Okay, so that's going to be etc. So this is the sigma notation that we're going to use it. Okay, so from a term, from the list, from the summation, you have to come up with the sigma notation to make look like the calculation more condensed. It's more packed, right? Okay. Now the next portion we're going to talk about is a recursive definition. So what does it mean by recursive definition? A sequence can be defined recursively. Okay, so a sequence can be defined recursively by using a recursion formula. So recursion, what does it mean by recursion formula? Should a definition list the first term. So when you're using recursion formulas or recursive definition, should a definition list the first term, they're gonna give you the first term or the first few terms, okay? And then describe how to determine the remaining terms from the given terms, okay? So for example, they might give you the first terms, and based on the first term, they're gonna give you the definition, the formula that we might calculate the second terms and the third term, the fourth term, and the fifth term, okay? But they need to give you at least one of the first term or maybe a few first term, it depends on the question. And based on that first terms or the first few terms, they're gonna give you some formula to come up with the next terms of that sequence. Find the first four term of the recursive defined sequence. Okay. So for example, for this question, they gave you the first term A1 is equal to 256, right? So A1 is equal to 256. And then they're gonna give you a of n plus 1 equal square root of an. Okay. So the n plus 1 term is equal square root of the previous terms an. So the n plus 1 term is going to be the square root of the previous terms an. Okay, so let's find out the first four term. Find the first four term of this sequence. Now, we're going to get when n is equal 1. Okay, so if n is equal 1, we're going to plug in n is equal 1. So 1 plus 1 is 2. So we can calculate A2. A2 equals square root of what? A1, right? Because n is equal 1. And what's the square root of A1? So it's going to be square root of 256. What is square root of 256, everyone? Let's use your calculator. Square root of 256. It's going to be 16. Okay, so we find out the second term, A2. So A2 is equal to 16. Now we're gonna move it on A when n is equal to 2. When n is equal to 2, we substitute n is equal to 2, we're gonna get A3. So A3 is equal to what? So A3 is by definition, by the given formula, is equal to square root of A2, right? Because n is equal to 2. So A3 is equal to square root of A2. And what's the A2? So we have A2 is 16. So we're going to take the square root of 16. We're going to give you 4. Okay, got the concept? Yes, everyone? Now we're going to try when n is equal to 3. When n is equal to 3, we have we can calculate A4, right? Because when n is equal to 3, n plus 1 is A4. So A4 is equal to square root of an, which is A3. And now we know A3 is already. A3 is equal to 4. So it's going to be square root of 4 equal 2. Okay. So I think that's really good right now because we have A1, A2, A3 is A4. So we have the first 4 terms of this recursively divided sequence. Okay. So based on the first term, we can calculate the second term. Based on the second term, we calculate the third term. Based on the third term, we can calculate the fourth term. So this is recursive sequence, recursively sequence. Okay, so based on the first term, based on a few given term, we can calculate the next term. So that's going to be recursion formula. Okay, recursive definition, recursive sequence. Okay, so part B, you can give it a try, everyone, based on the recursive formula. So A1 is equal to -10, A2 is equal 8. We're going to give you an plus 1 equal an minus 1. Okay. Okay, so we're going to try maybe the first. Yeah, so we have A2, so when n is equal 2. Okay, we're going to start when n is equal 2, right? Yeah. If you're going to start when n is equal 1, okay, yeah. If you're going to start when n is equal 1, we have A2s already because we're going to get n plus 1, so we have A2s already. So that's not okay. Now we start when n is equal 2. So when n is equal 2, we're going to calculate A3. So A3 is equal what? A3 is equal an is equal A2 minus n minus 1. So 2 minus 1 is 1 minus A1. What's the A2? A2 is equal 8 minus A1 was it 10. So it's gonna be -2. So we have A3. Now similar idea, we can try n is equal 3. Now when n is equal 3, we're gonna plug in n is equal 3. So we calculate A4. So A4 is equal what? A4 is equal an, which is A3 minus n minus 1. So minus A2. Okay, what's the A3? A3 we just calculate that -2 minus what's the A2? A2 is 8. So it's gonna be -10, right? Okay. So we have the first 4 terms already because we have A1, A2, we have A3 is A4. So we have the first 4 terms. Okay. Okay, so that's just a few practice questions of recursive definition. Okay. Now, before we're going to close in this section, we're going to take a look at this application. Okay. Okay, so let's take a look at this application in terms of a sequence. Okay, so Tony's pays $9.80 per hour for working at the Red Freight Limited. Each year he receiving $1.10 hourly raise. Give a sequence that lists Tony hour wage over the 10 years. So give a sequence that lists Tony's hour wage over 10-year periods. Okay. So for the first year when n is equal 1, right? So for the first year when n is equal 1, so Tony got paid. So A1 is equal $9.80. Now when n is equal 2, we're gonna get A2 is equal $9.80 plus $1.10 more. So it's gonna be $9. It's gonna be $10.90. Right? And then when n is equal, let's see n is equal 2. Okay, so the second year, that's what Tony gonna get. Now when n is equal 3, the third year we calculate A3, it's gonna be what? It's equal to previous year, $10.80, $10.90 plus $1.10 again. So it's gonna be $11 or $12 even. Right? Now when n is equal 4, we're gonna calculate A4, what Tony pays in the 4 years. It's gonna be the previous year. It's gonna be $12 plus $1.10 more. So it's gonna be equal $13.10. Now when n is equal 5, we calculate A5, the pace on the 5th year. It's gonna be the previous year, $13.10 plus $1.10. So it's gonna be $14.20, $14.20. And now we can try when n is equal 6, right? So we have A6 equal the previous year $14.20 plus $1.10 equal $15.30, right? Okay. So that's just the first when n equals 6, right? So when n is equal 7, 8, 9, and 10 also, right? So we have A7 is equal to the previous year, $15.30 plus $1.10. So this will be $16.40. When n is equal 8, okay, almost there, A8 is equal the previous year, $16.40. $16.40 plus $1.10. So it's gonna be $17.50. Now when n is equal 9, we can calculate A9 equal $17.50 plus $1.10. So it's gonna be equal $18.60. When n is equal 10, the last one, that's the question asking. So A10 equal the previous year $18.60 plus $1.10. $19.70. Okay. So this is gonna be the pay for Tony's over a period of 10 years. So at the 10 years, he's gonna get paid $19.70, right? Okay. Okay, so this is an example. So this is an application relate with the sequence, right? Okay, so this is an application relate with the sequence, or you might come up with the general terms of this. So let's give it a try. So everyone, what should be the general terms? So how we're gonna devise AN? Okay. Okay, so you might using recursives already, right? So you might using recursives already. So AN, okay, so or actually I'm gonna use a recursive definition. AN plus 1 is equal AN plus $1.10. But if I'm gonna use a recursive definition of this, I need to give you the initial so you can do the calculation. And we know that's A1. The pay for the first year is $9.80. Okay. Okay. So you might use a recursive definition, recursive sequence. Yeah. So A1 is equal $9.80 and AN plus 1 is equal AN plus $1.10. Okay. So this is an application relate with the sequence or series, right? Okay. Okay. Okay, now let's see what's in the next example. We might try solve it. Suppose that a single cells of bacteria will divide in two every 15 minutes. Suppose that the same rate of division is maintained for the next 4 hours. Give a sequence that leads the number of cells after after successive 15 minutes periods. So when n increasing over here, so for every period, it's represent 15 minutes, right? So it's 15 minutes, okay? And we have 4 hours. Let's see how many times of the 15 minutes it's gonna be, okay? So so you have to find out this, right? So n is gonna represent 15 minutes, yeah. So when n, okay, so when n is equal 1, it means that it's gonna be 15 minutes, yeah. Okay, what's the A1? So originally we only have a single cell over here, right? But it's gonna get divided by 2. So after 15 minutes, we're gonna get 2. Okay, so that's after the first 15 minutes, we're gonna get 2. And now similar idea when n is equal to 2. When n is equal to 2, it means we have 30 minutes already. So A2 will be, it's double the previous one, right? So gonna be 4. Now when n is equal 3, which is 45 minutes already. Now we got A3 is equal, it's gonna be double that, so gonna be 8. Okay. When n is equal 4, which is 60 minutes, which is 1 hour. So A4 will be equal, it's gonna double that, so gonna be 16. And then you're gonna do the same process over. So you're gonna find out how many bacteria we're gonna get after 4 hours. So let's finish the rest of the question over here, everyone. Have fun complete this, okay? So this is the conclusion of section 8.1. We talk about sequence and series. So now you might stop the recording, do the homework on my math lab. Okay, so see you next time for section 8.2.